Alessandro, but everyone calls me Chirpo. I decided his name doesn't mean anything in Italian just because Alessandro was too long. It was just used by my mother when I was not behaving properly. So I said, okay, let's go for a shorter one. So I'm an Italian guy, a bit Belgian as well. I live in London, and I'm a tech lead coach at Digital, which is an awesome company, consultancy company in London. So today I want to talk about the evolution of synchronous JavaScript. I want to talk about asynchrony. And I have a problem. I struggled a lot in the past, and I'm still struggling sometimes. How many of you struggle sometimes with async behaviors? Come on, don't be shy. Fine. It's fine because async is hard. It's super hard to write async code at the beginning, and it's even harder from my point of view at the beginning to test, if you're doing testing, in JavaScript. So, and remember that every time you use a set timeout in the test, a unicorn dies. And we don't have that many. So please stop using set timeout to test async code. As I was saying, async is hard. So at the beginning, I'm more a backend guy. I'm not a front-end guy. So yeah, I used to do website when full stack wasn't even a thing back in 15 years ago. So I was using jQuery, Prototype, or Scriptaculous. Okay, I don't know if anyone remember about those awesome libraries, but that was just managing the DOM, basically. And then 4 years ago, I had the opportunity, the awesome opportunity, to work in a team where I was moving a monolithic PHP application to an SOA, service-oriented architecture, microservice-ish architecture in Node.js. I say, awesome, fine, I'm gonna use JavaScript. But I was super sad at the beginning because I couldn't really deal a lot with async. And I was a bit frustrated, but then I realized that I wasn't the only one, and there's a reason for that, why I was frustrated, because we have a sequential brain, so we are not used to thinking in a sync way. Of course, you have to put aside voluntary, subconscious, or automatic brain functions, but we are not multitaskers. And again, I love JavaScript, and I think you also like that JavaScript, right? So if we think about that, this is a language that was written in less than 2 weeks, okay? And it has awesome things inside the language, but also some quirks part. But the fact that you can have high-order function, where you can pass functions as an argument, and also return function from functions, it makes a very great language. And we had a lot of talks, awesome talks this morning about frameworks like React, tools like Jest, WebGL, Three.js, JSON MVC. But sometimes we need to also think about the fundamentals of our language, even to understand and even also to contribute more to those awesome things that are extending JavaScript. As Brandon said, always bet on JavaScript, right? Or as Jeff Hadfield said, any application that can be written in JavaScript eventually will be written in JavaScript. And the other thing about the language is that, as we know, it's non-blocking. It's running on just one thread, but it's non-blocking, thanks to the event loop. So, unlike the other languages, never blocks. Handle I/O is very easy in JavaScript, and that's why it is an awesome language for the web. But again, we are still struggling sometimes with the sync. So let's get this example. Let's say that we have an awesome e-commerce, okay, and on the checkout page, it can be in the checkout page or can be even on the server side. While we want to do the checkout, we need to load the user info, the card items. We want also to load the exchange rates because maybe we want to also to give accurate currency in conversion, right? And then we calculate the total. Can we write something like this in JavaScript? Which is very step by step. We can, but it means that we are blocking, right? So if we are doing that on the front-end side, basically our UI will be completely frozen. If we are doing that on the server side, basically we can't accept any new connection until everything is finished. We have to wait. But again, what if waiting was easy as blocking? So that's why we will talk about the evolution of asynchronous JavaScript. We all probably know that today we have a lot of features inside the language, like, of course, callback, promise, and async await. But how did we get there? Why did we get there? As Claudia was saying this morning, knowledge is power, right? We need to understand also how things works in our beloved language. And again, what if waiting was easy as blocking? Think about blocking as a pool. This is very important. So basically, when I'm assigning a values, when I get something immediately, I'm pulling a value. Even though in this case, all these function calls are async, but even when you are assigning a direct value, you are pulling basically. Give me that value immediately. Block equals pull. So let's talk about a callback, right? Because everything started from there. So if we want to use callbacks, so basically, in order to have our awesome checkout, we need to pass callbacks to all the functions in this way, right? And I can hear you already screaming on the back, oh, that's a pyramid of doom, or the callback hell. You find this kind of thing on the web. I mean, you have tons of blog posts, articles, people complaining about that. But most of the time, I think we should complain ourselves, because sometimes you are just lazy. Not lazy in a good way where we automate stuff. Lazy in the fact that we just write code without thinking how to write it maybe in a better way. Because let's take this example. So this is a very small snippet of code written in Node.js, but doesn't care. Basically, we have a to-do list file, the text file. We are reading the file. We are adding a new to-do, and then we write back to the file. Of course, this code, I think, is very understandable, right? It's nothing crazy. It's not rocket science, probably. But still, we can see that we are starting a bit having this pyramid of doom. Can we do better? I think we can. For example, what we can do, we can go from this to this. So what we did here, basically, is the same thing. We are still reading a file, adding a new to-do to our to-do list, and then write it back to that same file. But I'm splitting in functions, and I'm giving name to those functions. So in this case, you can even reuse that code. So I said before, blocking is like pull, but waiting is like push. Because you need to wait for someone to push the value that you are looking for in order to get those values in general. So personally, I don't think the callback hell, the control flow in general is a very quirk or drawback or downside of callbacks in general, because I think that we can still do better as developers while you're writing code. Probably one of the things that annoys me the most sometimes is the loss of error handling. Because, for example, in Node.js, you have this convention where you pass the error as the first argument, right? It works, but it's a bit annoying because sometimes you don't really need that. Or in the past, we were used to have, or in the past, still even today, maybe you're using events like on success, on error, etc. Another thing about callbacks that maybe sometimes is very difficult to deal with is the inversion of control, or Hollywood principle. Don't call us, we will call you, right? So that's the idea. Let's say that retrieve exchange rates is an awesome service provided by an external company because your focus is on your e-commerce. You don't want to also take care about the precise currency value and stuff like that. So you're including an external library. So what could happen here is that we don't have control of our when calculate total will be called, right? Which is not bad per se, this kind of pattern. So we are using inversion of control and lots of applications and libraries and stuff like that. It's fine, but we need to understand also what could be, what issue we can face. Because in that case, we don't have any control on when our code will be called, right? What if it's never called? What if it's called more than once? What if it's called too early? Of course, we can set in place some flags, some checks, but think about putting all these flags every time you have a callback, an asynchronous callback. So yeah, sometimes it's a bit. And we said callback and async, but we know that in JavaScript, I mean, as you can pass functions, callbacks, but they are not always async. I mean, let's say if we think about map, for each, and stuff like that, they accept a callback, but it doesn't have to be asynchronous, right? So how can we tell if something is asynchronous? Well, the only way is to read the code, basically, which is fine, but I don't know about your application with Node.js or NPM packages, but it will take a bit of time to read everything. So again, I love callbacks. I think that are the fundamental unit of asynchronous in JavaScript, and they're super awesome. But sometimes, and given the fact that we are trying to find alternatives in the latest years, sometimes it's not enough. And again, what if waiting was easy as blocking? Again, this is the example, this is the kind of code that I would like to achieve. So let's talk about promise. Well, nowadays, we all probably use promises in general, right? We know that promises are this proxy. Sorry, 1 second. I thought it was beer, but okay. Well, so a promise basically is a proxy for not a necessarily known value when the promise is created, but the fact is that you can treat it as synchronous code, basically. And while I was trying to understand how things works in JavaScript, I discovered that JavaScript didn't have any notion about the fact that you can write async code, because it's not inside the language. You know, we have this event loop. Okay, but the event loop is not inside the language itself. It's something that is provided by the engine, like V8, Chakra, SpiderMonkey, etc. So the fact that you can have these async behaviors is only provided by the engine, or the VM, let's call it. So the promise is we know that they have to be async. Okay, so that's why in ECMAScript 6, basically, they introduced the job queues inside the language, which basically is like a small event loop, let's say. Okay, it's like a queue, so things can be always async, because when you call, for example, a then method on a promise, you will always do another trip. Unfortunately, job queues at the moment, it's not an API that you use from the language, it's just used internally. So, like Linus Torvalds always says, talk is cheap, show me the code. So this is how you create a promise, right? So let's say that you have a load user info function. We return a promise. We have a resolve reject as a function. If everything goes fine, we resolve with a callback value, with the sync things that we are getting. If there's an error, we reject them. So again, but here, we didn't get rid of callbacks. We still have the callbacks. Of course, this is just a snippet, very, let's say, it's a pseudocode. But we didn't get rid of any callback. We are just wrapping them, right? So at the end, we can write code like this, because you have the then method that it will give you access to all these async values that we are getting back. And also, we have the catch method, right? It's just something that at the beginning, when we start using promises, we always forget about. Because when we write code, we always think, yeah, all the things will always go fine. There will be no errors at all. And sometimes we forget about the catch, and we don't see any errors. So basically, control flow, even if from my point of view, it's not that a big issue, okay, because as I said, you can still write understandable flow code with callbacks, but it's solved, right? Inversion of control, it's solved as well, because once a promise is resolved, you can't change, the value can't change. If you're calling then multiple times, you will get always the same value. Error handling, we saw that with a catch, you can easily catch all the errors without passing errors around. Async or sync, it's always a sync. So it's a big win, right? But remember that I said that from my point of view, callbacks or pyramid of doom is not a real issue, because you can have the same thing with promises. And I was used to write this kind of code even at the beginning, because I'm lazy in the bad way sometimes, okay? So for example, here, we have to remember that a promise will always return another promise. So in this case, our code is a bit convoluted. So what we can do from this code, we can just go to this code, because we always return a promise, so we can put in a better, in a more linear way our code. And also sometimes we can, thanks to the fact that with JavaScript is a bit of an anarchic language, we can do whatever you want. So you can just easily do this, and you get the same result. One thing that I always try to push for is that don't use promise just for control flow. Because that's how people think that, oh yeah, promise, now I don't have to write all those kind of callbacks. You also have to understand that promise is also something else. Is that you are specifically saying that you want to wrap in a sync callback. And sometimes you don't need a linear flow. Also, because if you're writing open source code or code that will be used by other people that you don't know personally, if you're using promises in your libraries, your code becomes promise dependent. So if I have a system and I want to integrate your library and you're using promises, you are forcing me to use promises. So to promise or to call back? Well, if you have a library, as I said, you can support both. So this is an example of a very special function called foo. So basically, you have 3 arguments, and the last argument will be a callback, right? So you always return a promise. If the callback is specified, you're going to call it. Otherwise, you always return, you reject or resolve a promise. Doesn't matter. But in this way, you are basically supporting all the kind of paradigms, I say. So what are the other drawbacks of promises? Single value, as I said, once it's resolved, that's it. So single resolution sometimes is not good for streams. If you have streams, it's a bit tricky sometimes to use promises, or you have to use the other way around. And what about performancing? Well, the thing is that we didn't get rid of callbacks. The callbacks are still there, but we are wrapping. So yeah, logically, we can say that promises are slow, can be slow, slower than callbacks. But who cares? In the sense that most of the time, it's not a real problem. So again, we want to still get to that point. We are nearly there. But before talking about async await, we need to talk about generator. How many of you ever heard about generators? Okay. How many of you understand generator? How many of you is using generator in production? Okay. I'm not using generators in production at all. So what's a generator? It's a new type of function, basically, that doesn't behave like normal function, because when you call a function in JavaScript, it runs to completion. You can't stop it. So a generator is a bit different. We still have our foo function. In this case, the main difference is that we also have this star in front of the function name. And then we have a keyword like yield that basically is part of our generators. So let's see how it works. So if I'm calling the generator function, nothing will happen. I'm just initializing it. In order to run it again, I need to call next, because generator will give me back an iterator, something I can iterate with. And if I'm logging, and if I'm trying to understand what's the value when I call next, I will get an object with 2 properties. One is the value, which in this case is undefined, and the other one is that done with a boolean. In this case, it's false, so it's telling me that your iteration is not finished yet. So I call next again. In this case, cool. Basically, I have value equals 1, which is my x value, and done is true. So I don't have to iterate, and don't have to call next again. If you remember, since the beginning, we said that, yeah, we would like to block, but we can't block in JavaScript, right? It's monothread and stuff like that. But with yield, basically, we are pausing. So awesome. It's like kind of blocking things. So generator is just one side, because I said that generator gives you back an iterator, so why they didn't call it just iterators, for example? Because the other side is an observable sortish. So let's take another example. So we have this function bar, okay. In this case, we have x and it equals 14, and then we are using yield, the yield keyword, in an expression. Let's see what happens here. Again, I'm calling bar. I'm calling next to initialize the iterator, the generator. I'm checking the value. In this case, it's undefined, and done is false. In this case, I'm calling next, I'm passing a value. So basically, now, everything is done, so done is true, and the value will be 42. 14 multiplied by 3 is always 32. And so in this case, we are pulling, right? And we are also pushing, because we are getting a value and also pushing a value. So it's like a big win, right? And again, what if waiting was easy as blocking? So promises was solving some of our issues, having a sync code wrapped in a proxy object, and with generators, we are somehow pausing the flow, and all the other, in JavaScript will still run with other, let's say, with other functions. So what if we combine them? So basically, the iterator should listen for the promise to resolve. And then when it's resolved, the generator will call the next promise. So basically, we can have a code like this. So we have getTotal in this case, and we have yield in front of all our asynchronous call. And in this way, I'll wait that the user info will be resolved. Then I can check the cart items, and so on and so forth. But unfortunately, if I call getTotal, no one is managing the calling all the promises for me, right? So of course, in JavaScript, we have 10,000 libraries for solving all our issues. And in this case, for example, you can do npm install co, or if you are cool enough, you can use yarn. And woo, Facebook guy. Sorry. So in this case, I can pass co getTotal, and it will handle all this stuff for me. Pretty clear, I think, hope. So let's talk about async-await. Async-await is something that came out 2 months ago, right? More or less, with the new ECMAScript 2017 standard. There's not that much to talk about async-await, because basically what the way it works is what I just explained with generators and promises. But in this case, you don't have to use any external library in order to run the things for you. You can just simply put async, and then instead of yield, you will use await. And it is the same way of generators and promises combined. So these things and these things looks pretty similar. And I think it's even better. Why? Because in this case, I'm also telling that this function is asynchronous. And also, I'm specifically saying, where should I wait? Where I have another asynchronous call. So awesome. I'm super happy. I feel better now. But is async await, let's say, the answer to all our async issues? I don't think so. We will have something new even next year, in 2 years, 3 years. So far, so good. I'm not using async await that much. I'm just using it sometimes with Node.js, because you can have async await with the transpiler with Babel. But in general, I think our language is evolving so fast that I don't think this will be the final answer. For sure, it helps. So again, choose your way. Choose your way to deal with asynchronous. I'm not saying that now you have to use async await everywhere or just promises, because you always have a trade-off somewhere. I think callbacks are still beautiful. And if you think about it, we didn't get rid of promises, of callbacks or promises, because at the end, promises are still using callbacks, and async await will use promises. So this talk is about the language, but we should always keep in mind that when we write code for ourselves, okay? Because at the end of the day, it will be 0 and 1. So as Martin Fowler says, any fool can write code that a computer can understand. Just good programmers write code that humans can understand. So that's the main difference. That's the why and the how we get there with promises and async await. So one of the things I would like to do now is also to say thank you to this guy. I have so many people to thank for my career, and etc. But for example, if you want to know more, understand more about JavaScript, I suggest this set of free books, because basically you don't know JavaScript, you can download it even from GitHub. It's from Kylie Simpson, an awesome guy. Because sometimes we forget that we have one of the best jobs in the world, probably, because it's not so common in other industries, in other fields, to share, to contribute, to use free stuff. And from my point of view, it's very important to give back. For example, let's have a round of applause also to Gabi and all the organizers that today that let us flew in, having awesome food and all this kind of stuff. And I also have to thank my company, because my company basically allowed me to come here without taking any day of vacation, so pretty awesome. So yeah, thank you. And then again, I'm Chirpo. I'm a tech coach at Digital. We are hiring. free, come and talk to me. One thing. Unfortunately, there are no more jest stickers, right? But I have a digital bottle opener. So yeah, if you want, we can exchange that for jest stickers. Thank you so much.
Thank you very much, Chirpo.
Thank you.
Lots of questions.
No, just two. I'm hungry. You know, I didn't have my lunch.
You didn't have any lunch?
I was a bit nervous, but...
Okay, well, we'll get this over quickly. At least 27 people have said, can you do the dance of the dying swan from Swan Lake, please?
Let's do that together. No, let's do something more Spanish. Oh.
Well, that's it. No.
Can I just throw bottle openers?
Yeah.
Be careful, because it hurts.
Yeah, if it hits anybody in the eye, do not sue me.
Yeah, I have more. I can give you that later.
Next is going to throw bottles of beer at you.
Empty.
Try catch with async await feels bad. Should I just get over myself and use it?
I like it because probably my personal background is from very little bit of C in Java and mainly PHP. What I saw is that thanks to the spread operator, people what they are doing is like they're doing that like you do in Go. Have you ever seen Go lang code? So basically, it's 9.5. You say yes. What's that? Awesome, man. So the thing is that basically what you return, you will return an error or two different values, an error and then the value that you were expecting. So you can still do that. I see people that were complaining online, I don't like the try-catch, it feels so Java-ish. So they are using this technique with the spread operator in order to always just check for the error and stuff like that, instead of using try-catch.
Excellent. And a question from Clara from Spain. Who makes the best olive oil, the Spanish or the Italians?
Greece.
Ladies and gentlemen, Chirpo.